Hello everyone, today I'll be going over the basics of kinematics. So, before we get into the actual kinematics equations, there are a few things that I need to go through. First of all, I need to differentiate the difference between vector and scalar, which is really important when it comes to the difference between displacement and distance, and velocity and speed. Then we'll be going over the actual kinematics equations that is in your formula booklet and what they mean, and then we'll be going over how to solve simple vertical and horizontal motion. So let's first go over the difference between a vector and a scalar. In simple words, a vector is something that has magnitude and direction, and scalar is something that has only magnitude. Magnitude is essentially just a value or a size. The example I've given is 3 meters. So if it was a scalar having only magnitude, it would just be 3 meters. But if it was a vector, it needs direction. So I'd say 3 meters to the left. Vectors include displacement, velocity, accelerations. Scalar includes distance and speed. With vectors and scalars now differentiated, now we can go over the difference between displacement and distance. Essentially, displacement is just the vector version of distance. And the best way we can see this is through these examples. So let's say you start at point B and you want to go to point C. Now let's say there's no direct route to point C. You have to go this long-winded route and go like this and all that. And let's say this is, 3 kilometers. So that is the distance you traveled. However, this is not the same as displacement. So what is displacement? It would really just be the shortest route between B and C. It would be this right here. And this would be, let's say 1 kilometer. This is your displacement because displacement is always talking about your final position relative to your original position. It doesn't care how the route you actually took. It just matters your final position vs your initial position. So it'll always be the shortest distance between your points. Now, one thing that's important to note is that sometimes to show what direction is, we use positive or negative to differentiate the different directions. So because I put positive 1 kilometer here, let's say I went from B to A and this is, 0.5 kilometers. Well, if I wanted this to be displacement, I have to put this as negative because I'm saying that I went to the left this time, and in this case, I went to the right. This positive and negative is something really important to note, as this is always something you'll need for vectors, and it gets especially important when we move on to speed, velocity, and acceleration. So now we're going to move on to velocity and speed. And velocity is similar to displacement, it's just the vector version. So velocity is the vector version of speed. So let's say we had, a car and it's moving, let's say 10 meters per second. And it's moving to the right, so we'll say it's positive. And this is where the positive and negative sign become really important because acceleration will then tell you if the car is slowing down or not. So let's say this car had an acceleration of plus 2 meters per second squared. This means that acceleration is working in favor of the direction that the car is moving. So acceleration is also going this direction, which means that with every second, the car is going faster. So after 1 second, it's 12 meters per second, then 14, then 16, and so on. But what if this was a negative acceleration? So this is negative 2 meters per second squared. Well, in this case, let's move it to the other side so it's less confusing. So if we had negative 2 meters per second squared, then this means that acceleration is actually moving against where the car is going. So it'd be going this way. So the car is decelerating instead. It's slowing down. So it go 8 meters per second, then 6, then 4, and then all the way till it comes to rest. So here you can see how the positive and negative directions are really important when it comes to vectors. So you always want to make sure you keep track of the directions and really choose and stay consistent with your positive and negative direction. Also, you don't actually have to write positive, it's just omitted, but you do need to write negative. I just wrote it so it's clearer. Okay, now I'm going to move on to the actual kinematics equations, or what I like to call them the SUVAT equations. So these equations are in your formula booklet, so you don't need to worry about memorizing them. The only thing you really need to understand is what those symbols actually mean. So V is the final velocity of your object or person, U is the initial velocity, A is acceleration, T is time, and S is displacement. I've also put units for all of these symbols, and these are in SI units. It's convention that you put things in SI units. There are certain scenarios where questions might ask you to specifically convert to, kilometers per hour, for example, but usually they want it in SI units. So if you see something that's not in SI units, you usually want to convert it to meters and seconds. So here are some simple steps in solving simple kinematics problems. We'll be going over projectile motion later on. It's slightly more complicated than this, but the steps still apply. So number 1, you need to identify if there are different directions. If there are different directions, choose a positive and negative direction and stay consistent with it. Number 2, write down the kinematic values you are given and the one you need to find. So write down S, U, V, A, T, or whatever you have. 3, use the kinematics equations that corresponds with your given and unknown value. And this may take trial and error. And the reason for this is, well, there are multiple kinematics equations, and there is a possibility that it may take a little dilly-dally until you get the right one. One thing that's important to note when you're using the kinematics equations is that they assume that acceleration is constant. So if your acceleration is not constant in this problem, you cannot use these kinematics equations. You have to solve it another way. So that's something really important to note. All right, so now let's apply the steps that I've given you into an actual question. So a car, initially at rest, covers a distance of 27 meters in 3 seconds. What is the magnitude of the car's acceleration? You realize that they write magnitude here because they're only worried about the value. And the reason for this is they didn't actually give you a direction. They didn't tell you if this is 27 meters to the left, to the right, or whatever. So you don't actually know the direction, so you just give it as a value. As we've identified, there's no change in direction in this case. They just said 27 meters, 3 seconds, and 3 seconds doesn't have a direction, and since it was at rest, well, it didn't move any direction to begin with. So we can scrap off step 1. There is no different directions. So step 2, we write the values that we have. So we said it's initially at rest, which means that its initial velocity was 0. All right, it covers a distance of 27 meters. That's our displacement. S equals 27, and in a time of 3 seconds. All right, and now they want us to find the acceleration. So this is our unknown. Now that we have all these values, we can now look at the kinematics equations that we have in our formula booklet to see which ones apply. So looking at these values, it seems like this equation would apply the most to this situation. And I'm going to try this out to see if I'm correct. So let's substitute all the values that we have written here into our formula. So S is 27, U is 0, T is 3, and then we have 1/2 A and 3 squared. So this is just 0. This is just 9/2. So we have 9/2, A equals 27. Let's move this here. So this can just be simplified too, because 27 and 9 cancel out. Here it is just that. So then A would just be 6 meters per second squared. All right, now we're going to move on to a second example. So the last one was a horizontal motion. Now we're going to go into vertical motion. Vertical motion is a little bit trickier, and because there's direction involved more often. So here we have a ball which is tossed 1.5 meters above the ground with initial velocity of 3 meters per second. And they want us to find the maximum height reached above the ground. So in this case, direction is involved. So step 1 must be applied because all right, we have, maybe they're on a wall or something. This person's standing on a wall and they throw the ball upwards. So anyone who's thrown a ball in their childhood knows that the ball will start falling downwards. And that's because of the acceleration of gravity, which is often denoted as G. and this is usually 9.81 meters per second squared. For simplicity's case, we're going to round this to around 10 meters per second squared. So acceleration is moving downwards. However, we threw the ball upwards. So we have this conflicting direction. So now we have to choose what's a positive and negative direction. So I'm going to say up is positive and down is negative. So that means that my initial velocity would be plus 3 meters per second, and my acceleration is negative 10 meters per second squared. The 10 meters per second squared, or 9.81 meters per second squared, that's the acceleration of gravity. That's always going to be your acceleration when you're on Earth and you deal with projectile motion problems or vertical motion problems. Obviously, if you're not on Earth, it'll be different, but we're going to assume that this person is throwing a ball on Earth. So this is what we have right now, and they want us to find the maximum height. So S is the unknown, but now you might be thinking, wait, I only have 3 values. There's no way that this can apply to any Suvat equation because usually there's 4. So what do? Well, you have to note the keyword here, which is maximum height. This is something that questions will sometimes give you, and this is knowledge that you must know. When you throw a ball upwards, so if you throw a ball upwards, eventually it'll reach this maximum height. This is its max in its arc, and in this case, its velocity is 0. For a brief moment, the ball will keep going up, up, up. It will slow down because gravity is going against it, and at its maximum peak, it will go to 0 and then accelerate downwards again. So that's something you need to know. So V is 0. Just note that the keyword maximum height, V is always equal to 0. All right, now we can use a kinematics equation. So I'm going to use this equation because it has all the values. All right, now to substitute in this into the equation. So V equals 0, U is 3 squared, plus 2, and note, you have to put the negative 10 because directions and vectors. So this equals to 9 minus 20s. Therefore, the displacement equals 0.45 meters. But we're not done yet because they said the maximum height reached above the ground. And because this person was already above the ground by 1.5 meters, that means the height must be added. So it's 0.45 plus 1.5, which gives us 1.95 meters. There we go. So that's basically as complicated as it gets when it comes to vertical, like simple vertical and horizontal motion and kinematics. It obviously gets a lot more complicated in projectile motion, but if you have this basic knowledge in mind, projectile motion becomes a lot easier. So I suggest you do a lot of practice and really get a feel for the kinematics equations so you'll feel a lot more confident getting into projectile motion. I hope this video helped you, and thank you for watching.